Okay, so today we are going to start looking at what is called partial fractions, which basically means you take a fraction and you break it into parts. Okay, so that's basically what we're going to be looking at. It's quite a few steps, so if you look at what I have here written on this sheet, it has multiple steps to help you follow in order to know how to do it. So what we're going to do is we're going to do what's called a partial fraction decomposition. It's essentially taking the fraction and writing it in an equivalent way, but just writing it so it looks different. Okay, so we start with here, we've got 3 over x squared minus 3x. First thing that you do is you look at the denominator. Notice it says you are going to factor the denominator. We are not worried about factoring the numerator, so we do not factor the numerator. Okay, so that's a key, because when you look at some problems here we do in a little bit, the numerator is going to look a little intimidating, but that's not what we're worried about. Right now, the first step is to factor the denominator if it's possible. And if we looked at x squared minus 3x, we have a greatest common factor that we can take out. So the first step is going to be just to take out that x, and you're left with x minus 3. Okay. Step 2 is where we start creating these partial fractions, okay? So we are going to take what we just had. We have 3 over x times x minus 3. And we are going to take each factor in the denominator and break it apart into a piece, okay? So it says break each factor in the denominator into a partial fraction using a and b in the numerator. So we are going to take, we're going to put a in the top, and our first factor is x, so we just put that over there, plus b. We're going to figure out what a and b are here in just a minute, and then we put our second factor here. So our step 1 is we're taking that one that one fraction and breaking it apart into 2 pieces. If there was 3 factors in the denominator, we'd break it apart into 3 pieces, okay? So step 2, we broke it apart. Step 3, we are going to find the common denominator. We want all 3 of our denominators to be the same, because if you have all 3 of your denominators the same, that means that you can just solve the numerator. Okay, so we are just going to rewrite this here. We have x times x minus 3. Okay, and then we have a over x plus b over x minus 3. That's the same thing. Now we need to figure out what we need to do so they all 3 have the same denominator. Well, right now, our a over x has an x, but it is missing x minus 3. So we would need to multiply the top and the bottom of this one by x minus 3. And then if we look at our b factor, or excuse me, our term here with the b in the top, it has an x minus 3, but it is missing an x. And then the key idea here also is that if we have all of our denominators are the same, we can just solve our numerator. Okay, so step 4. All right, we are just looking at our numerator now. We are just looking at what I have highlighted here in green. So we are going to take 3, oops, daisies, let me erase that. I meant to have a pen there and I did not. So we're looking at just our numerator. Since our denominator is the same, we can solve our numerator. So we're going to have 3 equals a times x minus 3 plus b times x. And our goal is we are going to choose values of x that will allow us to figure out what a is and what b is. So it says choose a logical value for x that will eliminate a so you can find b. Okay, so step 1, let's think about what logical value we would use for x. Well, if I want to get rid of a, I'm looking here, if I take a times 0, that would get rid of a, which means I would like to say that x equals, I'm going to use the value x equals 3, and then I'm just going to substitute it into that equation. Okay, so I'm going to have 3 equals A times 3 minus 3 plus B times 3. Okay, well, what happens here, 3 minus 3 is 0, 0 times A, that cancels it. So we have 3 equals 3 times B. If we divide both sides by 3, we get that B equals 1. Okay, so now we know what B is, so now we're going to take this equation that we have written up here, and I'm going to take out B, and I'm going to put 1 in, because I know that B equals 1. So I'm going to rewrite that. 3 equals A times X minus 3 plus B is 1, so I'm going to say 1X. Okay. And then last thing here, we're going to choose another value of X to evaluate A. Okay, so let's think logically here. We can pick any value that we want. It doesn't matter. But if we want to pick out a value that would be easy, an easy value to pick would be X equals 0. Because if I put X equals 0 into this term right here, 0 times 1 is 0, and it eliminates it. So that makes our lives a little bit easier. So we're going to say 3 equals A times 0 minus 3 plus 1 times 0, which is just 0, so that's going to cancel. And we're left with 3 equals negative 3A. Therefore, A equals negative 1. A equals negative 1. Now, down here, I'm going to do a little thought bubble for just a quick second, and I'm going to erase this, but I said we could pick any value we wanted for X. Well, we already picked X equals 3 first. What if I picked X equals 1? I told you it should work for any value of X. So if I put X equals 1 in there, it should still give me that A equals negative 1. So I'm just going to show you that that actually works and it's correct. So I'm going to say 3 equals A times 1 minus 3 plus 1 times 1. I just put 1 in for X. And we have 3 equals negative 2A plus 1. If I subtract 1 from both sides, I get 2 equals negative 2A, and A still equals negative 1. It doesn't matter what value I pick, because it'll be true for all values of X. However, the reason I picked X equals 0 first is because it just easily eliminated that last term. So it really could go, you could pick a different value. If you don't choose to pick the same one that I did, that's fine. And then once we know what A and B are, go back to your partial fraction in step 2. This guy here. Oops. This guy here in step 2. And we're basically going to rewrite it, but now we have a value for A and we have a value for B. So we have 3 over X times X minus 3 equals, instead of A, we are going to put negative 1 over X, plus instead of B, we are going to put 1. And if you actually, okay, so we just basically went back, we figured out what A was, we figured out what B was, and we substituted them in to our original partial fraction equation up there on the top. Okay, so on that first example, we went step by step through everything we're supposed to do. The steps are listed here again. Let's see if we can go through the example just a little bit quicker this time. So step 1, we are going to factor the denominator if possible. And if you look, our denominator is factorable. So we are going to go ahead and just rewrite it exactly the same, except we are going to write our denominator in factored form. So we would have X plus 7 in the top, and then thinking what multiplies together to be negative 6 adds together to be negative 1, so we'd have X minus 3 and X plus 2. So our first thing we did was we just factored our denominator. Step 2, we're going to break it apart into partial fractions here, so that's our decomposition. So we're going to break each into a piece here. So we're going to rewrite the first thing the exact same. We're going to have X plus 7 x minus 3, and x plus 2. And we are just going to take each of those factors in the denominator. We're going to make them into their own piece. We're going to have x minus 3. We're going to have x plus 2. And we're going to put an a, and we're going to put a b in top. Step 3 is we're going to find that common denominator. So I'm just going to, again, rewrite everything. X plus 7, x minus 3, x plus 2 equals and then I need to have an x minus 3 and an x plus 2 in all of the denominators. So I'm going to go ahead and multiply this first one by x plus 2 on the top and the bottom. And this one I'm going to multiply by x minus 3, so that now all of our denominators are the same, so I can focus and just solve the numerator. Once our denominators are the same, we can just solve the numerator. So we have x plus 7 equals a times x plus 2 plus b times x minus 3. And again, we're going to pick a value of x that's going to eliminate either a or b. So let's eliminate a. So I'm going to say that x equals negative 2. Why negative 2? Because that would make negative 2 plus 2 is going to be 0, and 0 times a is going to cancel that out. So I'm going to say negative 2 plus 7. Again, I'm just coming here and substituting in, equals a times negative 2 plus 2 is 0. So we're going to say that's 0, plus b times negative 2 minus 3. That a cancels out. We get 5 equals negative 5b. So our b equals negative 1. Now I'm just going to take this equation over here and I'm going to rewrite it so that it has negative 1 in there for b. So I'm going to have, let's do this in a different color here. We'll go black. So I'm going to go x plus 7 equals a times x plus 2 plus b. Nope, we don't want to put in b because we know what b is. B is negative 1 times x minus 3. Okay, so now we need to pick another value of x that would make sense here. So I would probably, thinking logically, if I look over here, if I pick that x equals 3, that's going to give me 0 there. So I'm going to pick that x equals 3. So I'm going to say, again, we're just going to take this equation, 3 plus 7 equals a times 3 plus 2 minus 1 times 0, which is just 0, which is why I picked that number. And then I have 10 equals 5a, and a equals 2. Again, if you did not choose to use x equals 3 and you picked a different number, that's fine. You should still get the same answer. And then our final step is we just go back to step 2 here and we take our fraction that had a and b in it and we just rewrite it exactly the same, except instead of having a and b, we are going to put those values in that we found. A we said was 2 over x minus 3, and b we said was negative 1 over x plus 2. And we have a fraction that we've broken apart and decomposed into partial fractions. So let's go ahead. Now, the last one's going to be a little tricky because I did not put the steps on there because I'm not going to have the steps written out for you on the test. So let's go through the steps and see if we can remember how to do it without having the steps written out for us. Oh, look at that. It's all just one thing here. So we have x plus 8 over x squared plus 6x plus 8. So first thing I'm going to do, I'm going to factor that denominator. So I am going to have x plus 8 in the top. And then in the bottom, I'm going to have x plus 4 and x plus 2. My next step, I need to break those denominators apart. So I'm going to have x plus 8 over x. Actually, I can probably do that. I don't have to rewrite that whole thing there, do I? I could probably, now that it's factored here, I could just say a over x plus 4 plus b over x plus 2. Yeah, we can write it that way. I've broken it apart. I factored it and broke it apart there. I need to find a common denominator. So my common denominator, I have to have both an x plus 4 and an x plus 2. Well, with my a, I'm missing an x plus 2. So I'm going to go ahead and multiply the top and the bottom by x plus 2. My second term here, I'm missing an x plus 4. So I'm going to go ahead and multiply by x plus 4. There we go. And just like before, once our denominators are all the same, I can just solve my numerator. So I am going to have x plus 8 equals a times x plus 2 plus b times x plus 4. Again, now I just think, how am I going to figure out what a and b are? Well, I need to pick values of x. Well, if I look here, I'm going to pick -2. That's my convenient number that'll get rid of a. So I'm going to say x equals -2. So I'm going to say -2 plus 8 equals a times -2 plus 2, which is 0. So that's going to cancel. Plus b times -2 plus 4. So I get 6 equals -2 plus 4 is 2b, which means b equals 3. Okay, so then I'm going to substitute b back in there. So I'm going to take this equation here. I'm going to say x plus 8 equals a times x plus 2 plus, instead of b, I'm going to put in 3 times x plus 4. So now I need to pick a value of x. And again, I'm going to think logically here. It'd be nice if this value over here was 0. So I'm going to use x equals -4. If x equals -4, I get rid of that term right there pretty easily. So I'm going to say if x equals -4. Again, if you chose 0, because that's an easy number you like to choose, or you chose a positive number instead, that's fine. You should get the same answer. However, I'd like to see if I can find numbers that make sense. So, or not that just make sense, but make the problem a little bit easier. So we're going to say -4 plus 8 equals a times -4 plus 2, so 2 plus 3. -4 plus 4 is 0. 3 times 0, that's going to be gone. So I'm left with 4 equals -2a, so a equals -2. Then we just come back up here to our fraction, and we are going to have, and keeping in mind the partial fraction that we are using is what's written in red up here, okay, because that's what we started with. What we wrote in blue is what we multiplied the top and the bottom by. So we would have x plus 8 over x plus 4 times x plus 2 equals, well, instead of a, we are going to put -2 over x plus 4. Keeping in mind, we are not including that x plus 2 in this one because we are just doing that original partial fraction before we found common denominators. Plus b is 3 over x plus 2. So we've taken that original fraction and broken it apart.